Hello friends, welcome back to my channel. Now in this video we will learn about operations on real numbers, right? So in real number there is two type of numbers. One is rational and one is irrational. You have already learned about properties that are satisfied by rational numbers in standard 8, I think, and that is uh, commutative property, associative property and distributive property. Also closer rational numbers are closer under addition and multiplication. So commutative, associative and distributive, these three properties are also satisfied by irrational numbers, right? But when it comes to closure property, so irrational number are like wild cousin. Sometimes it follows closure property, sometimes it does not, right? So we cannot say that irrational number satisfy closure property in all the cases, right? So we will see how they react when we do operation between rational numbers and irrational numbers, right? Because we are talking about operations on real number. Rational and irrational both comes under real number. Now let us take a first case, that is, what if I add one rational number and irrational number. See, when we talk about properties, addition and subtraction both are the similar case. What I am saying is subtraction is part of addition. Like I have written 2 minus 3, right? This is case of subtraction. Now if I want to write it in the form of addition, I can write it as this, right? Answer of the first is -1, second is also -1, but it is in the form of addition where I have added two numbers, first is 2 and second is -3. So I can write subtraction in the form of addition. In same way, division in the form of multiplication. How I want to write this sentence in term of multiplication, so I can write it as 2 multiply 1 by 3. Answer will be same for both the cases, right? So subtraction is a part of addition and division is part of multiplication. So when we talk about properties, we can write it as plus or minus, subtraction and addition, right? Rational number and irrational number. Now we will see how it reacts by the example. What if I add one rational number with irrational number? What will be the answer? Rational or irrational? Irrational. Let's say I want to add 2 plus root 3. The 2 is rational, root 3 is irrational. What will be the answer? So answer is irrational, right? But I want to show you that the answer is irrational. What I will do is value of root 3 is 1.7 and all the decimal place, all the digits after decimal place. This is non-terminating and non-repeating number, and here I can put 2. Now what if I add this 2? Answer will be 3.7 and it will go on, right? So this is non-terminating and non-repeating. So 2 plus root 3 is irrational number, right? You can take any example that you want. If you add one rational number to the one irrational number, the answer will be always irrational, right? Now for second case, if you want to write an example, you can write simply as any example that you want, right? Answer will be irrational. Now second case, already we talked about addition and subtraction. Now it times to talk about multiplication and division. What if I multiply or divide one rational number with irrational number, right? But here we have one condition. So for the multiplication, if I multiply 0 with any number, whether it is rational or irrational, here 0, 2 is rational, 0 multiply 2 means 0 multiply rational number, answer will be 0. Here root 2 is irrational, answer is still 0, right? So if I multiply any number with 0, we all know that answer is 0. So there is no point of talking about this 0, right? So here I will take only rational numbers other than 0. So I can write is non-zero rational. right? Non-zero rational. If I multiply or divide non-zero rational with irrational, what will be the answer? Let us take example same number as we have taken in first case. 2 multiply root 3. What will be the answer? Answer will be 2 root 3. This is again an irrational number. 2 divided by root 3. This is irrational number. Or if you want to write root 3 divided by 2, here one is irrational and one is irrational. And this is again irrational number. So if I multiply or divide non-zero rational with irrational, my answer will be irrational always. So you have to remember these two, right? For example, I can write here 2 multiply or divide root 3. My answer will be 2 multiply or divide root 3, right? Or I can write 2 root 3, and for the second one answer will be 2 upon root 3, right? These both are rational. Now for third case. In the third case, what if I do operations between both the irrational numbers, right? What if I do operation between both irrational numbers? And here addition, subtraction, multiplication or division, anyone can be here, right? What if I do operation like addition, subtraction, multiplication and division between two irrational numbers? What will be the answer? Will it come rational or irrational? Let us see by example. First of all, I have to take irrational number. So let me take root 2. Here again irrational number. Plus root 2 or plus root 3, whatever you want to take, you can take, right? Let me take root 3. Root 2 plus root 3, these both number are irrational numbers, so our answer will be same as root 2 plus root 3. I am not writing the answer in decimal form, right? This is irrational number. Now, what if I add root 2 with another irrational number minus root 2? Answer will be 0. Here minus root 2 is also irrational and root 2 is also irrational. Addition between these two irrational number, my answer will be 0. So 0 is a rational number, as we all know. So in the first case, we got addition of two irrational number as irrational number. In second case, addition of two irrational number, we got 0. That means we got rational number. So we cannot particularly say that all the time addition of two irrational number is irrational or rational, right? Same way we can talk about subtraction, like as I have said earlier that subtraction is one part of addition. Same way we will talk about multiplication. Let me take root 2 multiply root 3. My answer will be in the square root 2 multiply 3, that is root 6. Now root 6 is irrational number, as we all know. Let me take another example, root 2 multiply root 8. Now what if I multiply these two in the square root 2 multiply 8, that is in the square root 16. Now square root of 16 is 4, as we all know. So in the first case, my answer is irrational by multiplying two irrational numbers. In second case, by multiplying two irrational numbers, my answer is rational number. So in the case of multiplication, we cannot say whether the multiplication of two irrational number is always irrational or always rational, right? It depends on the numbers. Now for the division, it is same, because division is one part of multiplication. We can write division in the form of multiplication, right? So if I do operations between two irrational numbers, my answer will be maybe rational or irrational, or irrational. So we will remember these three things. It can be asked you in MCQ type of question or in filling the blanks. Addition and subtraction of one rational and one irrational number is always irrational number. Multiplication and division of one non-zero rational number with irrational number is always irrational number. That is, any operation between two irrational number may be result in rational number or irrational number, right? So you can easily remember it by taking one example, right? Now, before moving to the examples, we will learn some identities or properties for the square roots. How to operate square roots, right? We all know that this is square root of 2. Let me take. We will understand these things by example, right? Here I have written a square equal to b, 3 square equal to 9. Now what if I remove square from this side? If I remove square from this side, I have to put a square root on other side, right? Here you can say if I want to remove square from this side, so 3 equal to, I have to write square root of 9. We all know that square root of 9 is 3. In the same way, a cube equal to b, 2 cube equal to 8. We all know this, right? Cube of 2 is 8. Now what if I remove cube from this side? I have to add cube root on the other side. That is, if I remove cube from this side, I have to add cube root in on other side, right? So cube root of 8 is 2. Cube root means the number that we have to multiply 3 times to get this number, right? Same concept as square root, here cube root. Now you can take any power, the concept is same. If I put n here, a raised to n equal to b, right? Here I don't have to give any example because I have taken n here. A raised to n equal to b. Now if I want to remove this power, I have to add nth root on the other side, right? So this is the first concept that we will remember. Now for second, we all know that 3 square equal to 9. So the process of square is we will multiply the same number. Here is, if power is 2, we will multiply this number 2 times, right? Now what if I do a square of any number with square root? Process is same. I have to multiply this number 2 times. Root 3 multiply root 3. Now this time answer will be 3, right? When I do a square of any square root number, what will happen? I have to multiply this number 2 times and it will result in square and square root both will be cut, right? So our answer will be the number that is in place of square root, right? What I am saying is, if I have to square a square root of 2, the process is root 2 multiply root 2. Now root 2 multiply root 2 is in under the square root, I have to multiply 2 multiply 2. This will be square root of 4. Now we all know the square root of 4 is 2. So square root of 2 and again square root of 2 is equal to 2. So simply I have to cut this 2, right? So square root of 3 and I have, if I do square root of 3, square and square root both will cut, answer will be 3. Why this both will cut? Here I have shown you a procedure, right? To do a square of any number, you have to multiply the number 2 times. Now if you multiply square root of a with square root of b, you can simply do a multiply b under square root, right? If I multiply 3 with 2, I can simply do 3 multiply 2, that is square root of 6. We all know that. So this is the first thing that you have to learn. The second thing is, when you do a square of any square root number, you get the simple answer. Before that, there is also one property that you should learn, and that is, you all know the identity a plus b multiply a minus b. The answer will be a square minus b square, right? You can take any number in place of a and b. Let me give you an example, 2 plus 3, or let me take 3 plus 2 multiply 3 minus 2. My answer will be 3 square minus 2 square, that is 9 minus 4, that is 5, right? Now when it comes to the number with square roots, like what if root a plus root b multiply root a minus root b, what will be the answer? You just have to replace a with root a and b with root b. Very simple. So replace a with root a, we have square here, minus b with root b, we have square here. So we have just learned that what is the square of any number with square root. We can simply cut square and square root, right? Answer is a. Now here also we can cut this, answer is b. So for square root of a plus square root of b multiply square root of a minus square root of b, our answer will be a minus b. So here you don't have to remember this, because we all know this. We can get this by just replacing a with square root of a, right? So it is our answer, a minus b. Root 3 minus root 2, root 3 plus root 2, what will be the answer? Simply 3 minus 2, that is 1, right? So you can try this method in any type of identities. Like you all know that a plus b whole square equal to a square plus 2ab plus b square for real number. In standard 8 you have done many examples for this identity. Now when it comes to the square root of a and square root of b, what will be the answer? You just have to replace the a with square root of a, and b with square root of b. Square root of a plus square root of b. What if I do a square of this both? My answer will be, I have to just replace a with square root of a, 2 square root of a square root of b, b with square root of b. Now here we all know that square of square root of a is a. Here 2, what is square root of a multiply square root of b? Square root of a multiply b simply. Now for this I can write b easily, right? So you can do this. So you don't have to remember specially like square root of b plus square root of a plus square of a square of square root of a plus square root of b is a plus 2 square root of a multiply b plus b, right? If you know this, you can easily get this. We will do example number 7, and that is 7 root 5 7 upon root 5 2 plus 21, fourth is pi minus 2. We have to check whether the answer of these numbers are rational or irrational, right? So we all know that 7 root 5. Now square root of 5 is irrational, as we all know. So if I multiply what we have learned, the three sentences in starting of lecture, that multiplication of one rational number and one irrational number is always irrational. So answer for this is irrational. Why? Because we all know that if I multiply non-zero rational number with irrational, my answer will be irrational, right? Now for this is the same case, but here we have division. So for the division, we all know that division of one rational number and one irrational number is always irrational. Here you have to remember that when I talk multiplication and division, I will take only non-zero rational number, right? And 7 is a non-zero rational number. Now for this root 2 plus 21, we all know that addition of one rational and one irrational is always irrational. So you can write it as here Now we all know that pi is irrational, so subtraction of one rational and one irrational is also irrational. So all the numbers that given in example 7 are irrational numbers. Oh, sorry, the previous one was example number 11. Now it is example number 12. Now I have to add these two numbers, right? So in the starting of lecture, I already told you that irrational numbers also satisfy the three properties: commutative, associative, and distributive property. So if I want to add these two numbers, it will be as simple as rational numbers, right? So what we will do? 2 plus root 2 plus 5 root 3 plus root 2 minus 3 root 3. You can treat it as a 2x plus 5y plus x minus 3y, right? You all know how to add this. For what will you do? First you place x, 2x plus x, then you place 5y minus 3y. You rearrange the sequence such so that you can take out a common number, right? Here we will do the same. 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. Now we will rearrange this question in such a way that we can take a common number out. So let me take 2 root 2 plus here root 2 and root 2. Here we have possibility to take out root 2 as common. So we will put these two together. Now here we have root 3 and root 3. So let me put 5 root 3 minus 3 root 3 together. Now I can take root 2 common. Here also I can take x common. So my answer will be 2 plus 1, because from here if I take out x, I have only 2, and from here if I take out x, there is nothing but 1, right? So here if I take root 2 common, my answer will be 2 plus 1 in the bracket, same as here. Now here if I take common root 3, my answer will be 5 minus 3, right? So root 2, 2 plus 1 is 3, root 3, 5 minus 3 is 2. Now if I write it in a simple way, 3 root 2 plus 2 root 3, this is my answer. So what I am saying is, you can do a simplification of irrational number. Just imagine a number that is in form of square root or pi or anything that is irrational as x or y, right? So it will be easy for you to solve these questions. Now we will do example number 13, and that is I have to multiply 6 root 5 to 2 root 5. What will be the answer if I multiply these two numbers, right? We already know that root a multiply root a is equal to a, or we can write in the form of square of square root of a. Now root a multiply root b is equal to square root of a multiply b, right? Now in this question, what if I have to multiply these two numbers? These are also in the multiplication, so I can write it as 6 square root of 5 multiply 2 square root of 5. Now 6 to the 12 and square root of 5 multiply square root of 5. Let me write it here. What will be the answer of multiplication of both the same square roots? My answer will be 5, right? Square root of 5 multiply square root of 5 is 5. So answer will be 12 fifths are 60. Very simple. Let me compare it with 6x multiply 2x. What will be the answer? My answer will be 12x. Now sorry, 12x square. Now here I have root 5 in place of x, right? I have taken x in place of root 5. So just replace root 5 in place of x. My answer will be square of square root of 5 is 5. 12 gives us 60. So what I am saying is, if you have any uncomfort with this type, you can take x as a square root of number that is given in your question and easily solve it. Now we will move on to the example number 14, that is 8 root 15 divided by 2 root 3. Now what will be the answer of this? Very easy, 8 root 15 divided by 2 root 3. Now as we all know that we can write root 2 multiplied root 3 as root 6. So as reverse, I can write root 6 as root 2 multiply root 3, right? I will do the same process here. Here I wait. Now if I want to cut down, I want to get root 3 in numerator because I have root 3 as a denominator. So I can write root 15 as root 3 multiply root 5, right? And in denominator we have 2 root 3. Now if I cut down root 3 to root 3, 2 to 8, that is 4. So my answer will be 4 square root of 5. This is my final answer, right? You can do it simply. What is the answer of a plus b multiply c plus d? We all have already learned in standard 8. Answer will be, first I multiply a with these two, now then I multiply b with these two. So my answer will be ac plus ad plus bc plus bd, right? Same way I can do it for this question. I have to multiply 5 to the 2 plus root 5, then root 7 to the 2 plus root 5. So this will become 5 multiply 2 plus 5 multiply root 5 plus root 7 multiply 2 plus root 7 multiply root 5. Now 5 to the 10 plus this is 5 root 5 plus here I can write 2 root 7 plus here I can write 7 multiply 5, that is 10 plus 5 root 5 plus 2 root 7 plus under root 35, right? So it is the same process that we have followed in standard 8, right? So it is very easy. Now second question is 5 root 5 and 5 root 5. 5 plus root 5, 5 minus root 5. What will be the answer? Marker is down. 5 plus root 5 and 5 minus root 5, right? This is the type of a plus b, a minus b. What will be the answer? We all know that answer is a square minus b square. So I can write here 5 square minus root 5 square, right? So 5 square is 25 and root 5 square is 5. Square and square root both will cut. So my answer will be 20. Very easy. If you know the identity, you can give answer in very easy form. Let me write it here. A plus b, a minus b equal to a square minus b square. Here 5 is in the form of a and root 5 is in the form of b. Now we will move on to the third question, and that is root 3 plus root 7 square of root 3 plus root 7. Now we all know the identity. What is square of a plus b? Square of a plus b is a square plus 2ab plus b square. We will do the same process here. This is the same question like a plus b whole square, right? So our answer will be a square. Here we have root 3 as a plus 2 a b plus b square, root 7 as b, right? So root 3 square is equal to 3. As we all know, square of square root will cut. Now for this I can write 2. Now in under the square root I have to write 3 multiply 7. For this I can simply write 7. Now 3 plus 7 will become 10 plus 2. Now 7 3s are 21. So it is my final answer. If you know the identity, just have to put the values instead of a and b, right? Now we'll move on to the fourth question, that is root 11 minus root 7, root 11 plus root 7. This is the same question like a plus b and a minus b, right? Multiplication of a plus b and a minus b. So what is the answer of a plus b multiply a minus b? Answer is simply a square minus b square. Let me write it in the form of a square minus b square is root 11 square minus root 7 square. Now root 11 square is 11, root 7 square is 7. So my answer will be 11 minus 7, that is 4. So 4 is my answer. Now as we have learned how to operate irrational numbers, how to add, multiply, subtract, divide, or do any this type of simplification to the irrational number or to the real numbers, right? Now what if we are doing some question or we are solving some examples, and in the denominator we have to meet a number with square root. What I am saying is, let me write it 2 plus 3 plus 3 multiply 5 upon root 3. What will be the answer, right? To simplify this type of numbers, it will be difficult for us if in the place of denominator we got a number with square root. So we have to do rationalization. What I am saying is, when we have root 2 in place of denominator, right? What if I want to convert denominator in the simple form? I can do one thing, and that is, what if I multiply and divide it with same number such that my denominator will become a rational number from irrational number? What if I multiply and divide it with root 2, right? So multiplication of 1 to root 2 is root 2. Division of square root of 2 with square root of 2 is 2, as we all know, right? So here we got denominator as rational number. What I have done is, if I multiply and divide any number with in the form of p by q with same number, nothing will change, right? Let me tell you with example. Here I have 3 divided by 5. Now when I multiply and divide it with 2, does my answer will change? Let me see. 3 2s are 6, 5 2s are 10. Is 3 by 5 and 6 by 10 are equal? Yes, because if I cut it, I can write 3 divided by 5, because 3 2s are 6 and 5 2s are 10, 2 will be cut, right? So what I am saying is, when we multiply and divide with the same number, nothing will change. So to remove the irrational number in the denominator, what we can do is, we can multiply and divide it with same number such that our denominator will become rational number, right? Let me give another example. When we have 1 upon root 3. Now what if I have to replace this denominator? Here we have irrational number. What if I want to make this irrational number rational number? I can just multiply and divide it with same number, right? So here I have 1 multiplied root 3 is root 3, and root 3 multiplied root 3 is 3, right? So the process of multiplying and dividing it with same number such that denominator will change into a rational number is called rationalization. We can call this type of number radical numbers, right? It will be difficult for us to do a solution in such a form when our denominator is in the form of irrational number. So we will simplify it by this method, right? So let me give you 2 or 3 examples. Now what is rationalization? As I told you, to replace denominator from irrational number to rational number, we will multiply and divide it with the same numbers, right? So this process is called rationalization. Now here we have example number 16, that is 1 upon root 2. Example number 70 is 1 upon 2 root 3. 2 plus root 3. Now we will do rationalization for these two numbers. 1 upon root 2, as we have shown it just before these examples, 1 upon root 2. If I want to rationalize this, I can multiply and divide it with same number, root 2, right? So my answer will become, in the numerator 1 multiplied root 2 is root 2, in the numerator root 2 multiplied root 2 is 2, as we all know. Let me write it here. Root a multiply root a will become a, and root a upon root b will be square root of a by b, and root a multiply root b will be square root of a multiply b. So this is our answer, right? In the question example number 17, you have asked that you have to rationalize this number 1 upon 2 plus root 3. Now there is one term called conjugate of number. Conjugate of number. Now what is conjugate? If the number is a plus b, the conjugate of number will be a minus b, simply, right? If the number is a plus b, conjugate of number will be a minus b. So here we will do the same thing. We will multiply and divide it in such a way that we can remove root 3, right? So we will multiply and divide it with conjugate of number. And what is conjugate of number? For 2 plus root 3, conjugate of 2 plus root 3 is 2 minus root 3. We will multiply and divide this number with 2 minus root 3. Why are we doing this? Because if a plus b and a minus b both are in multiplication, the answer will be a square minus b square. Here we have square, so we can remove square root with square, right? Let me tell you what will be the answer. If I multiply 1 with 2 minus root 3, numerator will become 2 minus root 3. Now in the denominator I have 2 plus root 3 multiply 2 minus root 3. 2 plus root 3 multiply 2 minus root 3. Isn't it in the form of a plus b and a minus b? So answer of a plus b and a minus will be a square minus b square, right? So the numerator will be 2 minus root 3 and denominator will be square of 2 is 4. Now square of root 3 is 3. So my answer will be 2 minus root 3. Yes, simple as that, right? What I have said is, if the number is here I have monomial, here I have binomial. So for monomial, you can rationalize the number just by simply multiplying, dividing it the same number with denominator, right? Here I have root 3, so I have multiplied and divided it by root 2. So I got the rational number in place of denominator. This will be easy for us to solve. Now when it comes to the binomials, what we will do is, I will multiply and divide it by conjugate of number. And by saying conjugate, I mean that I just have to change the sign between these two numbers. Here I have 2 plus root 3, so I can simply multiply and divide this number by 2 minus root 3. I just change the sign, and we will call it conjugate of numbers, right? So when we got a binomial in the form of denominator and we have to rationalize it, what we will do is, we will multiply and divide the number by changing the sign between these two numbers. So here I got 2 minus root 3 as the numerator, and denominator there will be a pattern such that a minus b multiply a plus b, right? Pattern like this, a plus b multiply a minus b. So our answer will be a square minus b square for denominator. When it comes square root will we go, so our answer will be 2 minus root 3 divided by 1. So we get an easy denominator to solve the questions, right? Now here you don't have to focus on numerator, you just have to focus on denominator. I want to rationalize this number. What will I do? Here I have binomial. Don't afraid when both the numbers are irrational. you just have to focus whether it is monomial or binomial. For the monomial, you just simply multiply this number and divide this number, right? Now here we have binomial, so what we will do is we will multiply and divide this number by conjugate of the number, and conjugate of number is just simply change the sign between these two numbers. Here we have minus sign, so I have multiply and divide it with plus sign. When someone asks you why we will multiply and divide it with conjugate of number, just tell them that we got this form as a denominator, and answer of this is a square minus b square. So when square comes, square root will go. So in numerator I have 5 multiply root 3 plus root 5, and in denominator I have root 3 minus root 5 multiply root 3 plus root 5. Very easy, right? Now 5 multiply root 3 plus root 5 is, this is distributive property. So very simple, 5 root 3 plus 5 root 5. Just multiply this with both these numbers, very easy. Now in the denominator it is in the form of a minus b and a plus b. My answer will be a square minus b square. Here I have root 3 is a form of a and root 5 is a form of b, so a square minus b square, right? So in the numerator there is nothing that can be simplified, so just write 5 root 3 plus 5 root 5, and in denominator I have root 3 square minus root 5 square, that is root 3 square is 3 minus root 5 square is 5. So my answer will be 5 root 3 plus 5 root 5 upon 3 minus 5 is minus 2. Now you can remove minus sign from denominator and change the sign of numerator. This is all the process that we have already learned in previous standard, right? So this is our final answer. Method is you have to multiply and divide it with the same number. If the denominator is monomial, you just multiply and divide it with the same number as given on the denominator. If denominator is binomial, you do rationalization with conjugate of that number, that is you just change the sign of that number. Now this is example number 19, 1 upon 7 plus 3 root 2. Now what we will do is 1 upon 7 plus 3 root 2, it is binomial, so we will multiply and divide it with conjugate of number, and that is just change the sign between these two numbers, right? Now 1 multiply this is 7 multiply 3 root 2, so numerator will be 7 multiply 3 root 2. For denominator it is a plus b and a minus b, so answer is a square minus, in place of b we have 3 root 2, a square minus b square, right? So numerator will be 7 minus 3 root 2, same it is, and denominator 7 square it is 49 minus 3 root 2 square. So squaring of this type of number is equal to 3 square multiply root 2 square. I can simply write it as, right, a multiply b square equal to a square multiply b square. I can do it when it is in the form of multiplication, not in the addition, because when it is in the form of addition I have to use this, right? So it is in the multiplication, so I can write it as simply 3 square multiply root 2 square. Now 3 square is 9, root 2 square is 2, 9 2 is 18, simple. So 3 root 2 square is 18. So my answer will be 7 minus 3 root 2 divided by 49 and minus 18 is equal to 1 and 3, 31, right? This is my answer. Now we will learn how to represent a number like square root of 3.5 on number line. We have already learned how to represent irrational number on number line, right? Like square root of 2, square root of 3 on number line. Now we will learn how to represent this type of number on number line. I have written all the things that you have to remember from this lecture, right? Now how to represent square root of 3.5 on number line. We will use the concept of, let me just give you the concept behind this. What if I have to represent square root of 9 on number line? we all know that square root of 9 is 3 and we can easily represent 3 on number line. Let me use a different method. How can we represent square root of 9 in the number line, right? Now if I want to represent square root of 9, I will take a line with length of exact 9 unit. Now if I extend it for 1 unit, here it is 1, so the full length of point A, B, C, full length of A to C will become 10 units, right? Now let me take an exact middle point of line A and C, and this is middle point of line segment A and C. Let me mention it with O. So length of AO will become 5. Here is a simple process, just understand it. It will be easy to represent root 3.5, a square root of 3.5 on number line if you learn this process, right? What I have taken is length of AO will become 5 because length of AC is 10 and O is middle point of A and C, right? And same way this length will be 4 because length of OC will be 5. Here the length of this line segment BC is 1, so length of O will become 4. Now what if I draw a semicircle? I draw a semicircle with center point A and radius of AO. Semicircle will look like this, right? It touches here because the length of OC is 5 and length of radius for semicircle will be same for any point, right? So OC is 5, OB is 4, BC is 1 and AO is 5. Here AO is radius. Now let me draw a line segment here. Let me draw a line segment on AC that passes through a point B and it is perpendicular to AC. Perpendicular on AC that passes from B. It will touch semicircle here and let me name it D, right? If I join O and D, what will be the length of O and D? Tell me. What will be the length of OD? Because it is a radius of a semicircle and radius for semicircle is equal for all the points, and for this circle we have radius is 5, so length of OD will become 5, right? Now length of OB is 4 and because it is a perpendicular the angle is 90, so we got this triangle. This point is B, this point is D and this point is O. Length of this side OD is 5, length of this side OB is 4. What will be the length of this side DB? Very easy, we all know that length of this side will be 3. Why? By Pythagoras theorem, length of BD square plus OB square equal to OD square. We all know that, right? Let me take x here. Length of BD is equal to x square plus OB square equal to 4 square is 4 square. Let me write it 16 simply, and OD square is 25 simply. So x square will become 25 minus 16, that will be 9. So x equal to 3, right? So length of this side will become 3 and our question is same. We want length of 3, right? We want length of square root of 9, that is 3. So if I want to find this length, this will be the process, and the main concept is I have to use a Pythagoras theorem and right angle triangle to find this length. Now I can write any number here, my answer will be same or the process will be same, I get desired answer. What I am saying is, if here I used this method for finding square root of 9, that is 3. Now if I want to find square root of 10, what I am saying is, if I want to find square root of 10, I will do the same thing, and this is, I will draw a line segment AB with length of 10 units, then I will extend it for 1 unit, so the total length of AC will become 11 units. Now I will find the middle point of AC. Length of this side will be 5.5, because 5.5 multiplied 2, that is 11. Now this side will be, this is length of 10, so this side will be 4.5, right? Here we have 1. Now in the triangle ODB, if you apply Pythagoras theorem, you get the length of BD as square root of 10. If you want to check it, you can check it, right? So similarly, if you want to find length of square root of 3.5, we will do the same process. Let me do it from start. What I have done is, first we will draw a line segment of length 3.5. You can easily draw it with your scale and pencil, right? Let me name it A and B. This is of length 3.5. Now second step, I have to extend it by exactly 1 unit. Here I have mentioned that I will use same unit. If I have taken 3.5 centimeter, I will increase 1 centimeter here. If I have taken 3.5 foot, I will increase 1 foot here. If I have taken 3.5 inches, I will increase 1 inch here, right? So for AB, I have taken length as 3.5. So draw a line segment AB with length 3.5, then extend it with exactly 1 centimeter. Now find a middle point of AC. Here I have given name this point C, right? Find exactly middle point of AC. You can easily find it with your scale. Now take a compass, put a point on this point named O, and pencil on A, and draw a semicircle. Let me draw it for you. This is a semicircle. Now draw a perpendicular on line AB, line AC passing through point B. Perpendicular on lines AC passing through point B. So here is a perpendicular that is drawn on line AC and passing through point B. Now when it touches to the semicircle, mark it as point D, right? Now just join O and D, right? The length of this side will be same as the AO, and what is AO for us? Total length is 4.5. Now the middle point of 4.5 will become 2.25. So here we have 2.25. OB is 2.25 minus 1, that is 1.25. So if you do apply Pythagoras theorem to the OBD to find length of size BD, you will get answer as square root of 3.5, right? As we have shown in earlier example. So this is the simple trick. And if you don't want to do this, what I am saying is, if you don't want to do this calculation, right? If you have just simply asked in your question that mention square root of 3.5 on number line, you can stop the drawing process here, and here the length of BD is always what is asked in the question, right? So just measure the length of BD in your scale and mention it in the number line. Here we have 0, 1, 2. So mention it in between. The answer will come somewhere here, right? So this is very simple. What is the method? Let's say you have asked to draw square root of 7.5 on number line. What will you do? You will draw a line segment of length 7.5. extend it for 1 unit, right? Now you will find a middle point of this point, that is A and C. Now taking a middle point as a center of circle, you will draw a semicircle, and that will look like this. Now if you draw a perpendicular on AC passing through B, it will touch your semicircle somewhere here. Now length of these 2 points BD is always a length of question that you have asked. So just simply measure this length and take your scale on a number line and mention it when it stops, right? So it is your answer. So in this lecture we have learned some identities, operation on decimal numbers and rational numbers, what will be the result if I add or multiply or divide or subtract between rational and irrational, what will be the answer. We have learned it. Now we have also learned how to mention this type of number on number line. We have learned how to rationalize the numbers that are radical numbers. Radical means if we have irrational numbers in the form of denominator, how to rationalize this type of numbers, what is conjugate of number, how to do multiplication of two square roots, how to do division of square roots, and how to do in simplification of numbers where contains irrational numbers or numbers with square roots, right? Now in the next lecture we will complete exercise number 1.4. So thank you for watching this video, and if you have any doubt you can mention it in comment section. Thank you for watching this video.